So as we continue in Unit 3 with our I/O management, and we're exploring all the various reader classes, there's another reader that we should take a look at. And so buffered reader is going to be very similar to buffered stream, only instead of buffering against a byte stream, it's going to buffer on a character stream. So just a quick overview of what we'll be showing with the buffered reader presentation here is going to be a quick introduction about buffered reader, just to make sure everyone understands what this class is intended to do. Then we'll look at the class declaration and the constructors you can use. We'll look at how to create a buffered reader, because it's essentially like a filtered type of reader where it requires an underlining reader to be passed to it. We're gonna go ahead and go through the simple steps for buffering a console-based user input, for instance, or just talk at least in plain English with what that process is. And then we'll look at the methods and some sample code. So a buffered reader in Java is a buffering input character stream that can read text from the buffer. So rather than directly underlining the input stream or other text sources. So it adds the buffering capability to the underlining input character stream so that there is no need to access the underlining file system for each read and write operation. So with buffered reader, it's good in two important ways, right? So the first is it wraps another reader and adds a buffer that will read the text much faster and improve your performance by buffering the input. So the same rationale as to why we want to know about the buffered stream, the buffered reader is the same way. Otherwise, what happens is when you're reading off of a text file, you're actually having to request from the OS to read a character at a time. So with buffered reader, you can have a buffer. It's like a bucket that's in memory that you read into your buffer initially. And then as you do your reads, you're pulling it from the buffer. And when the buffer empties, then it'll go back and do another read operation to fill the buffer back up until there's no more contents left inside of the file or whatever the source is to be able to read from. And so that's very much more performative as opposed to requesting to effectively have the OS open the file each time so you could read an individual character. And it provides a read line method too that allows you to read a string of characters, arrays, and text lines. So those are the two really nice things that buffered reader has. So a quick note, a buffered stream stores a large number of characters from the stream so that more than one character at a time can be read, when a buffered should be, oops. And when a buffered stream is empty, it is filled again with as much text as possible. So just like I was saying before, as this relates to the byte streams, it's true with the character streams as well. So it'll fill again with as much text as possible, even if it's not all of it is immediately required. And so each time we make a read, it makes all the future reads much, much quicker and more performant. Okay, let's look at the buffered read class declaration. So buffered reader is a subclass of the reader class that extends object class, and it implements closable, auto-closable, and the readable interfaces. It is also a superclass of the line number reader. So your general syntax, if we were to look at the source code, would look like this: a public class buffered reader, which it extends the reader class, and it would implement closable, auto-closable, and readable. So buffered reader was introduced in Java 1.1 along with all the other readers and writers, because initially in Java 1 you just had byte streams, and then by Java 1.1 they decided that it was to also open it up to have character streams as well. And of course all of these are in the java.io package. So a quick gander at the constructors. There are two primary constructors we want to look at for buffered reader. We have a buffered reader where you can, obviously for both of them, you have to pass in an input stream. So you create an input stream and then you wrap that input stream around a buffered reader instance, and the buffered reader provides that input stream, that additional buffer that we can then pull data into from the stream and read from there. So the constructor creates a buffered reader object that buffers the input stream specifically by specified by the input stream, and it uses this particular constructor has default size of the buffer, and the default buffer size is 8,192 characters, which is pretty large for most purposes. Now, if for any reason you need it to be smaller or larger, you can actually control that. So the second constructor has a second parameter where you pass in as an integer what your buffer size is. Now, it has to be greater than 0. Okay, so if we wanted to create a buffered reader object, the general syntax would look like this, right? So we would use the new constructor on buffered reader, and we pass it some input stream that is, it has to be a subclass of reader. So for example, we could do that, for instance, with system.in, right? That is a reference, like system.in is actually implements off of or extends off a reader. So we can create a new input stream reader using system.in, using that stream that initializes to the keyboard. And so that's going to give us our input stream reader. So that's our reference to reader here. And then we could pass that reference to reader into the buffered reader. So we always need to construct some reader that passes into buffered reader, because again, it's like a wrapper class. It wraps around a pre-existing instance of something else, but adds new functionality to it. So after both statements execute, the BR here, our buffered reader, is going to be a character-based stream that is connected to the console through system.in. So that's effectively what's happening in those 2 lines of code. So the simple steps for buffering the console-based user input. So Java buffer reader can be used to buffer or store the data input received from an input stream reader object. So these are going to be the kind of simple steps we can follow if we want to buffer console-based user input. So first, we would create a input stream reader object using the standard input stream. So here's our input stream, system.in, and around system.in, we'll create a reader. So system.in is a byte stream. Here, we're going to pass that in so we can get an input stream reader. So now we're going to have a character stream here. And so we'll save that into ISR. And then what we'll do is we'll create a buffered reader object and pass the reference of our input stream reader to that constructor. So we'll create a new buffered reader with the input stream reader here. And so we'll save this new instance of the buffered reader into BR. Then we would perform all of our input operations on the buffered reader on the BR. And then when we're done, we just have to go ahead and close the buffered stream. And when we close the buffered stream, it'll automatically close all the underlining streams to close. And so there'd be effectively the input stream reader, and the input stream reader would be using the system.in. System.in kind of manages itself, but you can see how then just each one tells the other to close. So you don't have to manage how many streams are actually open at any given time. Okay. So let's talk about some of the buffered reader methods. So in addition to the methods that is inherited from the reader class, the buffered reader class also provides some useful methods for buffering character-based streams. So we have methods you should be aware of, and I've added all these to the slide so you have kind of the ability to use this as a form of documentation. But ones that are pretty critical are obviously being able to close your buffered reader. You have a lines method. This method returns a stream that contains the text of lines read from this buffered reader, right? And so that's going to pass a stream itself of string data types using generic parameter types there. We have the ability to mark, where we can pass in an integer value, and this method marks the present position in the buffered stream. And then we have a Boolean method that we can check if mark is supported or not. We have a read method. This method's used to read a single character from the buffered stream, and it returns it as an integer value, which when we get that integer, we can cast it into a character. But we do that because we also want the sentinel value of -1 to let us know when we hit the end of the stream. We have the read method overloaded, right, where we can pass in a character array along with an offset and the number of characters we want to read as the second and third parameters. So that method reads the characters into a portion of the array. We have a read line method, and so that read line method reads an entire line of text from what the user has typed, and it generally is used to read a string from the keyboard. So it returns a string that contains the characters read and returns null if an attempt is made to read at the end of the stream. We have a ready, which recall that that's a method is used to verify whether the stream is ready to be read, whether there's something in there or not. So it's true if there's something in the stream to read, and it's false if there's nothing in the stream to read. We have a reset method, which resets where the mark is at. So reset and mark are used in conjunction to one another. And we have the skip method. And so the skip method allows us to skip over the number of characters that we pass in as this long integer value. And so it's going to return the number of characters that got skipped. So all these methods, except for lines and mark supported, will throw an exception named IO exception. And actually, let me cut this from here, because this should really be reported here. Note. My computer's a little laggy. Okay, perfect. And unfold that. Perfect. Okay, so that's just the note that is true for all these methods and not just that one. Okay, let's take a look at some example of buffered reader. So let's create a program where we can go ahead and read data from a file. So again, our source code is on the slides, which I will share with everyone. But let's take a look at it from the IntelliJ so that we can actually fiddle around with the code, have interactive code, run the code, look at the output that gets produced from the JVM. So I'm going to go to BufferedReader tester here. I'm going to open that up. I'll close this other file here. Okay, so let's see here. Let's see if so. Welcome to Java programming is what the expected contents is. Welcome to Java programming is indeed what is inside of my file.txt. Okay, so let's walk through this. So I'm going to import my buffered reader, right, from the java.io package. But recall, I can't build this in isolation. I need a pre-existing reader to pass into it. So I'll also go ahead and import a file reader. And so I'll also have to import an IO exception. And it's been true for anything related to IO. We need to either throw an IO exception or we have to do a try-catch block. I'm going to create a new class to build this example application in. I'll just call it BufferedReader Tester1. I'll create a main method, and I'll just throw my IO exception there so I can focus on just the code in the block and the method. Here, I'll create a string that represents the file path. It's going to be inside of this source directory will be my file.txt. Then I'm going to create an object of file reader, right, using that file path and its constructor. I'm going to save a reference of that. Then I'll go ahead and I'm going to create my buffered reader, pass a reference to that file reader that we created in the line before it. And now I'm going to save my buffered reader. Now I'm going to create a string, which is going to be the line of text that I want to grab. And here, while my line of text, which is a string, not an integer, right? One of the cool things about the buffered reader is I can grab entire lines. So I'll just go ahead for my buffered reader and grab a line. And until my line of text is not null, and let me go ahead and execute this so we can see what's going to happen. So as long as I'm grabbing text and I don't get a null reference, I'm going to continue to go ahead and print that line of text I grab. And so it's going to be that welcome to Java programming. And the moment that I run out of text here to grab with the read line, that's going to return a null, then I'll go ahead and exit out of that while loop. And there we can see we were able to read the contents of that file. Okay, I kind of want to show some more things that we can do with our buffered reader. So why don't we try to create a application, a basic application where we read string data from the keyboard and display that onto our console. So again, all of our source code is on the slides, and I have comments embedded in there and the expected output and whatnot. So let's go and take a look at the next example though in IntelliJ. So I'm going to do my imports. I'm going to import BufferedReader class. I'm going to import my IO exception. Now here, since the goal is to get my input from the keyboard, I don't have to import another stream, another reader class to pass to BufferedReader, right? I'm going to use the input streams that are defined inside of system. So that's going to be the goal here. But I guess what I do need to do though is even though I won't get a, even though my system.in is the stream I want to use, I do have to actually import an input stream reader, right? Because I need to convert it into a reader. I need to build a reader around the byte stream that then gets passed to BufferedReader. So I do have to import my input stream reader. Here we'll go ahead and we will define a class, the BufferedReader tester2 class, so that we can have our main application that's going to throw an IO exception. Here, I'm just going to do this all in one line. So we might not have seen this before, but what I can do is I have my byte stream that is from system.in, and from system.in, I'm going to construct a reader instance using the input stream reader around that. So this is create a new instance of that. And I need that reader instance so that I can pass it to the BufferedReader constructor. And once I've constructed that, I can save that in my BufferedReader variable BR. Then what I'll do is I'll go ahead and have a string here that will save what the user types in. I'm going to have a prompt, inner lines of text, and then inner end to quit. And then we'll just do a do while loop here, where we will, from our BufferedReader, read the entire line into the string. Then we'll print that string out. And so long as string does not equal end, we'll be able to keep getting input from the user. So let's go ahead and just run this. Okay, that's my prompt. So hello world. Okay, print out hello world. This is fun. Print out this fun. And then when I do end, we'll end out the application. Excellent. Okay, let's look at another example where we'll take an input of characters and display its ASCII value. So recall that each character that we have can be represented, right, as an integer value. That's why when we read them, it has a numeric value that can then be cast into a glyph, into a letter or number, right, into whatever the character set binds to that ASCII value. So let's take a look at the actual ASCII value itself. So this is going to be our source code. It's our output, but let's jump right over here into IntelliJ and we'll look at the code from there. So here we're going to import BufferedReader. We're also going to import the input stream reader. We're going to go ahead and import IO exceptions. We're going to create a new class for the sample code BufferedReader tester3. Here, I'm going to create a main method and it's going to throw the IO exception, so I don't need a try catch block. Here, I'm going to do this nested constructor invocation where I'm going to use the input stream. It's going to look at the keyboard, right? And then I'm going to convert that into a character stream, so a reader, so input stream reader, and then I'm going to convert that into a BufferedReader instance, and I'm going to save that BufferedReader instance. Now I can grab characters, right? That's what a reader is designed to do. So I'm going to create a prompt, enter a character. I'm going to read that character as an integer value, right? Now to highlight what we can do here, I can cast that integer value into a character and then cast it back into an integer. And we're just go ahead and print this out so we could see that, for instance, if I type in like the letter Q, that's going to be 113, right? Now, if I go ahead and let's rerun that again. If I do capital Q, that's going to be 81. And you can see that each unique letter, it's uppercase, it's lowercase, it's a numeral letter or a special symbol letter, like a plus sign, will all have its own ASCII value associated with it. So like if I wanted to say, oh, what's the ASCII of like the plus sign, for instance, would be 43. Excellent. And so that's going to be just a quick, some quick exposures to the buffered reader.